Replacing an existing electrical panel and keeping it in the kitchen is possible if there are no obstructions in front of it. Several factors should be considered to ensure the replacement complies with electrical codes, prioritizes safety, offers convenience, and adequately handles the electrical load. Firstly, adherence to electrical code requirements is paramount. The electrical panel must remain accessible and free from obstructions such as permanent fixtures, furniture, or appliances. Accessibility is crucial for maintenance, repairs, and in case of emergencies. Secondly, safety is a primary concern. The panel's location should be in a safe and easily accessible area, away from flammable materials and areas where it could be damaged by falling objects. Sufficient clearance around the panel is necessary for safe operation and maintenance. Thirdly, convenience plays a role in the panel's location. Placing it in a convenient spot facilitates easier maintenance and repairs. This includes ensuring adequate lighting and workspace around the panel. Fourthly, the electrical load is a critical consideration. The replacement panel must have sufficient amperage and circuit capacity to handle the electrical load of the kitchen and any other circuits it supports. This may require upgrading to a higher amperage panel if the existing one is insufficient. Now, let's outline the general process for replacing the electrical panel. Firstly, turn off the main power supply. Locate the main breaker or fuse that controls the power to the panel and turn it off. This step is crucial for safety. Secondly, remove the existing panel. After ensuring the power is off, disconnect the wires from the existing panel. Carefully remove the panel from the wall, taking care not to damage the surrounding structure. Thirdly, install the new panel. Mount the new panel in the same location as the old one, or in a new location that meets code requirements. Ensure the panel is properly secured and level. Fourthly, connect the wires. Connect the wires from the house to the new panel according to the circuit diagram. This step requires careful attention to detail to ensure all connections are correct and secure. Fifthly, turn on the main power. After all wires are connected and the panel is properly installed, turn on the main breaker or fuse to restore power to the kitchen and other circuits. Sixthly, test the panel. Check that all circuits are working properly and that there are no power issues. Use a multimeter to verify voltages and continuity. Consider these additional points. If the new panel is larger than the old one, it may be necessary to enlarge the opening in the wall to accommodate the new panel's dimensions. If the existing wires are old or damaged, they may need to be replaced to ensure safe and reliable operation. It is highly recommended to hire a qualified electrician to perform this work to ensure it is done safely and correctly. Working with electrical panels can be dangerous, and a professional electrician has the expertise and equipment to handle the job safely. Some things to consider when choosing an electrical panel. The amperage rating of the panel should match the service entrance rating of the home. The number of available circuits should be sufficient for the current and future electrical needs. The panel should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL. The National Electrical Code, NEC, provides specific guidelines for electrical panel installations. Some key NEC sections include Article 110.26, which covers working space about electrical equipment. It mandates sufficient clear space in front of the panel for safe operation and maintenance. The depth of the working space depends on the voltage and condition of the installation. For example, for a 120 volts to ground or 208 volts to ground system, the minimum depth can range from 3 feet to 4 feet depending on whether there are exposed live parts on both sides of the working space or grounded parts. Article 312 addresses cabinets, cutout boxes, and meter socket enclosures. It specifies requirements for the installation and construction of enclosures for electrical equipment. This includes provisions for securing the panel to the wall and ensuring proper grounding. Article 408 covers switchboards, switchgear, and panel boards. This article outlines the requirements for the construction, installation, and protection of panel boards. It includes provisions for overcurrent protection, grounding, and marking. Article 230.70 details the location and accessibility of service disconnecting means. It requires that the main disconnect for the electrical service be readily accessible and located at a convenient location, either inside or outside the building. NEC Table 310.15 B16 provides ampacity ratings for conductors. This table specifies the allowable ampacity of different sizes and types of conductors based on their insulation and the ambient temperature. When selecting conductors for the electrical panel, it is essential to consult this table to ensure they can safely carry the intended load. Grounding is a critical aspect of electrical safety. The NEC requires that all electrical panels be properly grounded to provide a path for fault current to return to the source, tripping the overcurrent protective device. The grounding electrode system should be connected to the panel using a grounding electrode conductor of the appropriate size. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting electrical circuits from overload and short circuits. The NEC specifies the requirements for overcurrent protection in Article 240. Circuit breakers should be properly sized for the circuits they protect, and they should be tested periodically to ensure they are functioning correctly. Here are some additional safety tips. Always turn off the power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, hire a qualified electrician. Regular maintenance of the electrical panel is essential for ensuring its safe and reliable operation. This includes inspecting the panel for signs of damage such as corrosion, loose connections, or overheating. Circuit breakers should be tested periodically to ensure they are functioning correctly. The panel should be kept clean and free from obstructions. When working with electrical systems, it is crucial to follow all applicable codes and regulations. The NEC is the primary standard for electrical installations in the United States, and it is updated every 3 years. Local codes may also apply, so it is essential to check with the local building department to ensure compliance. Proper planning is essential for a successful electrical panel replacement. Before starting the project, assess the existing electrical system and determine the electrical needs. Select a new panel that is appropriately sized for the current and future load requirements. Obtain all necessary permits and inspections. Gather all the necessary tools and materials, including the new panel, wire connectors, electrical tape, and testing equipment. Following these steps will help to ensure a safe and code-compliant installation. If the existing electrical system is outdated or overloaded, it may be necessary to upgrade the service entrance to increase the capacity of the system. This may involve replacing the service entrance cable, meter, and main disconnect. Upgrading the service entrance can be a complex and expensive project, so it is essential to consult with a qualified electrician to determine the best course of action. Arc fault circuit interrupters, RF size, are designed to protect against arc faults, which can cause fires. The NEC requires a size to be installed in many circuits, including those that serve bedrooms, living rooms, and dining rooms. When replacing an electrical panel, it is a good idea to install a size to provide enhanced protection against electrical fires. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electric shock. The NEC requires GFCIs to be installed in many locations, including bathrooms, kitchens, and outdoor areas. When replacing an electrical panel, it is a good idea to install GFCIs to provide enhanced protection against electric shock. Surge protective devices, or SPDs, are designed to protect against voltage surges, which can damage electronic equipment. The NEC recommends installing a SPD at the electrical panel to protect the entire electrical system. SPD can help to prevent damage to sensitive electronic equipment caused by lightning strikes, power surges, and other electrical disturbances. Proper labeling of circuits is essential for safety and convenience. The NEC requires that all circuits be clearly labeled to indicate their purpose. When replacing an electrical panel, take the time to properly label all circuits to make it easier to identify and troubleshoot problems in the future. Use a circuit directory to document the circuits and their corresponding labels. A whole house surge protector is designed to protect all the electrical devices in a home from power surges. It is installed at the main electrical panel and provides a first line of defense against surges entering the home. A qualified electrician should install a whole house surge protector. Smart electrical panels offer advanced features such as energy monitoring, remote control, and surge protection. These panels can provide valuable insights into energy consumption and allow users to control their electrical devices from their smartphones or tablets. Smart panels can also help to prevent electrical fires and other electrical hazards. The cost of replacing an electrical panel can vary depending on several factors, including the size of the panel, the complexity of the installation, and the location. It is essential to get quotes from multiple qualified electricians to compare prices and services. Be sure to ask for a detailed breakdown of the costs involved, including labor, materials, and permits. Here are some common problems that can occur with electrical panels. Overloaded circuits can cause circuit breakers to trip frequently. This can be a sign that the electrical system is not adequate for the current load. Loose connections can cause overheating and electrical fires. It is essential to inspect the panel regularly for loose connections and tighten them as needed. Corrosion can damage the panel and its components. Corrosion can be caused by moisture, chemicals, or other environmental factors. It is essential to protect the panel from corrosion. Rodent damage can damage the wires and components in the panel. It is essential to seal any openings in the panel to prevent rodents from entering. The lifespan of an electrical panel is typically 25 to 40 years. However, the panel may need to be replaced sooner if it is damaged, overloaded, or outdated. If you are unsure whether your electrical panel needs to be replaced, consult with a qualified electrician. Consider a load calculation. Before replacing an electrical panel, perform a load calculation to determine the electrical needs of the home. This will help to ensure that the new panel is appropriately sized for the current and future load requirements. A load calculation takes into account the square footage of the home, the number of appliances, and other electrical loads. Obtain permits and inspections. Electrical work typically requires permits and inspections from the local building department. Be sure to obtain all necessary permits before starting the project. An inspection will ensure that the work is done safely and according to code. Notify the utility company. Before replacing an electrical panel, notify the utility company. They may need to disconnect the power to the home during the work. The utility company can also provide guidance on the electrical service requirements. Document the wiring. Before disconnecting any wires, take pictures or create a diagram of the existing wiring configuration. This will help to ensure that the new panel is wired correctly. Use a wire tracer to identify the circuits. Disconnect the old panel. After turning off the power, disconnect the wires from the old panel. Be sure to label the wires to make it easier to reconnect them to the new panel. Use a wire stripper to remove the insulation from the ends of the wires. Install the new panel. Mount the new panel in the same location as the old one. Ensure that the panel is securely fastened to the wall. Use a level to ensure that the panel is level. Connect the wires to the new panel. Connect the wires to the new panel according to the wiring diagram. Be sure to use the correct size and type of wire connectors. Tighten the wire connectors securely. Install the circuit breakers. Install the circuit breakers in the new panel. Be sure to use the correct size and type of circuit breakers. Label the circuit breakers. Test the new panel. After installing the new panel, test it to ensure that it is working properly. Use a multimeter to check the voltage and current. Test the circuit breakers to ensure that they are tripping properly. Clean up the work area. After the project is complete, clean up the work area. Dispose of any debris properly. Store the old panel safely. Replacing an electrical panel can be a challenging project. If you are not comfortable performing the work yourself, hire a qualified electrician. A qualified electrician has the knowledge and experience to perform the work safely and according to code. Here are some things to consider when hiring an electrician. Get recommendations from friends or family. Check online reviews. Verify the electrician's license and insurance. Get a written estimate before the work begins. Ask about the electrician's experience with electrical panel replacements. Ask about the electrician's warranty. Be sure to follow these tips to ensure a safe and successful electrical panel replacement.